let us solve a problem. So, this is a simple problem. I have a slot over here and a slot over here. There is a vertical slot and there is a horizontal slot, and there is one mechanism like this moving. Okay. So, as this moves, this comes like this. I hope you understand, right. Now, what is asked is, if I know the velocity of this, let us say this is at an angle theta, okay. I think theta is given as 45 degrees. Let us say this is moving at a velocity Va, this is 8 meters per second, and what is the length of this? This is 3 meter length, okay. And what is asked of us to find out is how much is this rotating, or in other words, what is the angular acceleration of this angular acceleration of angular velocity of this particular rod, okay, at this position, because depending on the position the angular velocity may change. So, position is given to you at that instant, what is the angular velocity, that is the question that is asked. How do I solve this problem? Let us see. The first thing that I have to do in all these exercises is fix fixed frame of reference. It is like biblical statement, you have to fix, okay, that is the Gita. So, I will fix a frame of reference, this is x and this is y, okay. So, a fixed frame of reference is now given, this is B, this is A, the length is given, I need to find out the angular velocity, okay. Very simple. If I know the moment of this with respect to the fixed frame, what is the moment of B is another question that is possible. So, let us look at that. The moment of B or the velocity of B should be equal to the velocity of A plus velocity of the line connecting them, correct. So, velocity of A plus velocity of B with respect to A. And what is velocity of B with respect to A? We have already done that exercise. This is equal to Va plus omega cross R of B with respect to A. And this is the equation I have. Now, what is the next step that I have to do? What is asked for is, what is omega equal to? Okay. I have this equation. The next thing I have to do is examine what quantities I know and what quantities I do not know. Can we do that? Now, is it possible to find out RB with respect to A, given that there is a position that I have already shown you, that it is at an angle theta, say 45 degrees. Is it possible to find out R of B with respect to A? Yes, R of B with respect to A is nothing but RB minus RA. If this is the position of B, and this is the position of A, then it is simple, RB minus RA will give me R of B with respect to A. Okay. So, this is pretty simple. Since I know this particular RB with respect to A, because the length is also given, this I know, complete vector I know. What is the direction of omega? since this is on the plane, the direction of omega is perpendicular to the board. So, I know the direction of omega. What do I know here? I do not know the magnitude, I know the direction. Is that clear? This I am just going to circle so that you know this is something that is to be found out. Do I know VA? Of course yes, VA is given by 8 meters per second times I. I am using a capital I here to denote that it is a fixed frame of reference, alright, because later on when you have a rotating frame of reference you could use a small I, okay. So, I am going to use capital J, capital I, okay, and therefore here do I know the direction of VA? The answer is yes. Do I know the magnitude of VA? The answer is yes, it is 8 meters per second. So, this is completely known, this is completely known, the direction is completely known, the magnitude of omega is not known. Let us look at VB. VB, do I know the direction of VB? Do I know the direction of VB? The answer is yes, it is along this direction, right. I can take it to be upward so that the magnitude can be negative, and so I know the direction of this is along the J direction, which means only magnitude is not known. So, now it is very simple, all that I do not know is the magnitude of VB and the magnitude of omega. These are the two unknowns. How many equations do I have? Remember, this is a vectorial equation, right. I will have, if I write it completely, it is the magnitude of VB times the J vector, correct, plus magnitude of is equal to magnitude of VA is given by 8I, okay, it is because in the positive direction, plus magnitude of omega, okay. This is n direction, this is RBA, okay. So, n is nothing but k, correct, cross what is RB with respect to A? This length minus this is 3 meters, and therefore, this is 3 cos 45 and this is 3 cos 45, correct. So, it is crossed with 3 by root 2, alright, 3 by root 2 times J minus I. Is this clear? Okay. What is K cross J? K cross J will come in here, and that will be nothing but, how do I find out? I, J, K, if it is in the cyclic order, I will get a positive when I do a cross product. So, K cross J will be a minus I, right, and I have a K cross I, K cross I is positive, so I will get a J, alright, and therefore, here I should be getting plus omega, I will take this out. So, 3 by root 2 times K cross J is I minus I minus J. How do I now separate into two equations? Very simple. I will take all the I terms separately, all the J terms separately, and equate them. Okay, that is very simple. There is no I term here, so it is 0. The component of I here is 0, is nothing but 8 minus 3 by root 2 omega. I do not need the other equation because what is asked for is the value of omega, and value of omega is simply 8 times root 2 by 3. Okay. What is the unit of this? Per second. Okay. Radians per second. That is it, over. This is what is very important. I need to now look at this as a vector equation, and therefore I will have two unknowns that I will solve for. Whichever unknown I need to solve for, I will appropriately take the component in relation to that. Okay. In most of the problems, this is how you will understand solving.